Both of these functions are what kind of functions?
I was talking, linear.
How do you know?
Because the highest exponent is 1.
Man, y'all act like y'all really in the 11th grade. Okay, so the first question. What is the boundary point? What is that?
0.
0. Okay, so the easiest way I found, make your X and Y table, put your boundary point in the middle. So 0 is my boundary point. I want 2 points on the left side and 2 points on the right side. At least. Okay? If you want to put 3, cool. But at least 2 points on the left, 2 points on the right.
You're not going to write 0 down bottom too?
I'm going to show you. That's why I'm making 0 longer. Put an asterisk mark over your boundary point. This is just so that you know something special. Okay? So, -2. Am I going to use my top linear equation or my bottom linear equation?
The top.
The top, because -2 is less than 0.
It's okay.
Okay? So that will give me what?
4.
4. Okay? Now, -1. Am I going to use my top linear equation or my bottom linear equation? The top one. So that gives me 2. Did you notice that whatever was on the left was the top equation?
I guess so.
And probably whatever's on the right side will be the bottom equation. Let's find patterns. Okay, 0, because that is my boundary, I'm going to plug it into, there you go. So the first one, what kind of circle is this going to be? Open. So if I plug in 0, I get 0. Now I put 2 dots and then I write open. Just so I'll know that when I graph. Now notice that this point, because a point has to have an X and a Y value, this point is 0, 0, which is known as the origin. Okay? Now, because this is my boundary point, I'm also going to plug it into my second equation, and my value is what here? 1. And I'm going to write closed, because I have my equal sign, so it's a closed circle. But what is this point? 0, 1. Not the same point.
Oh, that's where the new thing started?
Very good. You got your brain turned on today. Alright, so if I plug in 1, it goes in which equation?
The bottom one.
Thank you. So that should be 2. I plug in 2, it goes in which equation?
The bottom one.
So that should be 3. Okay. So, please, at this point, if you have any questions, please raise your hand. It's easier if you make the table like this than if you make it vertically, I found. Yes, Emma?
So for the X values, I can put anything?
Technically, but to make it best, I would take my boundary point, put it in the middle, and then 2 points on this side, 2 points on that side. Now, where that's different, say you had a fraction. Okay, let's just take a side note. Say I had a function that was this. Okay, I had a linear function that was like this. What kind of X values would I want to pick for this?
That can be divided by 2.
Thank you. I want to pick only X values that can be divided by 2 so that I don't have a what? Fraction or decimal. Okay? So I would pick stuff like 0, because 0 over 2 is 0. I'll pick 2, 4, 6, 8, just so I'll have whole numbers. Okay? Other than that, you probably want consecutive numbers. Okay? Alright. Now the graphing part. Once again, how do we read?
From left to right.
Left to right. So that's how we're going to graph. Now, we said both of these equations were what kind of function? So we know off the top what's going to be drawn. Straight lines. That's why I taught you how to recognize a function by looking at it, so that when you got to this and you graphed it, you wouldn't graph a parabola when you had a linear equation.
Okay.
Or vice versa. Okay? So, our X values are -1, -2, 1, 2, well, not actually 2, but 3. Okay? Well, 1 and 2, yeah. My Y value only goes up to 2. Oh, it goes up to 4. Okay? Straight? Okay. Now, all of my points are going to be closed except for this one right here. Okay? So, first I got -2, 4. So that's about here. Of course, mine isn't going to be as accurate as yours because you actually have a Cartesian plane. That's a nice word. Okay? -1 goes to 2. Okay? And now 0, 0 has to be open circle. Okay? Everybody straight, please. And of course, like I said, mine is not going to be perfect.
How do you graph the 0 again? The open and close?
Because this had less than, no equal sign, it's an open. This had the equal sign, so when I plugged in 0, I got 1, so that's the close.
Yeah, how you graph that?
Because this is a closed circle, this is a closed circle, that's open. Close, close, open.
Oh, okay.
Okay? Any other questions at this point?
No.
Don't say no because you can't speak for other people.
So the closed circle.
Yes.
So anything to the left of the 0 is our first line.
Right.
That was it.
Okay.
Oh, and the closed circle, that's for the ones that don't got the line.
We'll watch when we get through this. Can I move on now?
Yes.
Okay, now, I'm starting here. I graphed this one. Now I got to graph this. This is 0, 1. So at 0, 1, I have a closed circle. And then at 1, 2, I have another closed circle, because that's just a regular point. And then 2, 3. So it's something like this. So notice, whatever my x value is for my boundary point, I'm going to have 2 points there, but they both can't be closed. Because that would go against the definition of a function. Because a function says every x value has to have one and only one y. Now, remember that this open circle means that this value will always get forever close to it but never touch it. It's almost like a what? Asymptote. Very good. That's what the open circle means. That it will forever get close to it but never touch it. This closed circle means is what? Touching it. Okay? So, let me say this again. At your boundary point, you're going to have 2 values. One has to be open, one has to be closed. Do you understand? Okay? Also, I will take off points if this line crosses over into this area. Because this is called a what point? Boundary. And I can't cross the what? Boundary. So a lot of you like to do this. I'm going to take off points if you go past the boundary point. Do you understand? If you're at the boundary point, you better stop. Now you can put the arrow on this side and on this side, but do not cross the boundary point. Ms. Durant.
So the boundary point is always 0 or no? No.
It's not always unless I say always. Now you guys can look at this first page. What's the boundary point for number 2?